Hello guys. Today's lesson is on chain rule. Okay, this is very important in maths and 5 because almost every question have some chain rule, whether it's product rule, whether it's quotient rule, whether it's implicit differentiation, or it's a logarithmic differentiation. There's always chain rule, so it's very important to understand uh, this step. So I'll start with basics. So from your formula sheet, you have this equation. If you check under chain rule, you have y function of ux there. So that's why your chain rule, another name for chain rule, is a function of a function. So if you check here, it's I have a function. So let's say function f. Let's say function f it's sine. Then inside your sine, I have u, which is function cos. So which means that thing will be something like this: sine of cos. You see, just like that. So now how do you differentiate this? So from here, if I have to differentiate, I must first start with f, then go to u. Then inside u, if there's another one, then I multiply with it until the end. So what I mean is you always start with the main function. You check which one is the main function. So we can see cos it's inside your sine. So that's the main function. So if I differentiate, I'll start with sine. The differentiation of sine is cos. Then now go inside sine. What do I have inside sine? I have cos. What is the differentiation of cos? It's minus sine. Then that's your answer. Minus cos sine. You see? But let me do another example. Okay, I can erase here. This is a video. You can just go back and look at it. Okay, so now let's make it three functions now. I like working with tricks because trigonometry can be the one which is a bit confusing. So let's say I have a function of sine cube. Let's say I have, what do I have? Let's say I have x x cube. Okay, let's say x exponent 4. So now this is exponent 4. So it shouldn't, it's not 7. Okay, let me erase and write it properly. This is exponent 4. So now what's the main function? So most of you might say it's sine, but the main function is not sine, it's exponent 3. Remember, when 3 is here, it means it's for the whole sine. So which means I can rewrite this as sine x exponent 4. That sine cube means this. So now the main function, do you see now, it's 3, exponent 3. And how do we derive exponent 3? We multiply and subtract 1. And another thing with chain rule, you do one thing at a time. So I started with 3. After doing the 3, nothing changes. I still have this thing exactly as it is. Then now I'm done with 3. Now I'm going to the next function after exponent 3, which is sine. If I derive sine, I get cos. Do you see x exponent 4 did not change because it's one thing at a time. Then after cos, now I'm going to x exponent 4, which is 4x cubed. You leave your answer here. You don't simplify, guys. Every time, don't simplify. Leave your answer there. Then you are done, just like that. Okay, let me do one more example. Let's say I have y. Let's say I have ln. I also like ln. Let's say I have ln of what? Okay, let's say I have ln squared. Then I have ln of, for example, okay, let me just put anything, x squared x squared tan x. Yeah, this one is good. X squared tan x. They are multiplying, which means it's a product rule. So now do you see this ln squared is like sin cube. So this squared is for the whole ln. It's for the whole ln. That's what it means. But remember, if I have squared here, this is something this is something I would like everyone to avoid. If I have squared there, just write it as 2 ln to avoid having many things. Just write it like this as 2 ln to avoid having many things. And remember, this one inside you can also expand it to 2 ln x squared plus 2 ln tan x to avoid having many things. But if we can just apply, the answer will be the same. But if we just apply what do we call it, quotient rule from here, let's say you didn't do this 2 ln, you will still get the same answer. Let's see. Remember, the main function is 2. So if I start with 2, I'll be left with 1. So I'll have this thing. Then I'm done. So the next function is ln. What is ln? It's 1 over everything. Then the next one is to multiply by derivative of this. Remember, I started with 2. I started with 2, which is number 1. Then I came to ln. Then the third one is to do this one. So this, which is what I'm doing, which is product rule. So we know product rule, I'll have x squared sec squared plus 2x tan. You see, that's my answer there. Just like that, and you are done. Okay, let's do examples. Now I was just explaining how chain rule works. Let's do examples. Okay, this is August 2019. So you have y equals to square root of 3x plus square root of 2x plus square root of x. Then how many marks? 4 marks. 3 marks. It's only 3 marks. Okay, then the first thing, if you want to make your life easier, always, if we check the main function is half. The big square root, that's your main function. Then after that, you have another big square root, which is another half, which have what? Which have 2x plus square root of x, which is x exponent half if you want. So now you have to start with the main function. If I start with that half, what happens? I have half, then I have this bracket exponent what? Minus half, because we multiply and subtract 1. Then what happens inside? Nothing changes. You still have this thing exactly as it is. Then multiply by what? Now we derive inside the bracket. If I derive inside the bracket, my 3x will be 3. Then now I'm going where? I'm going to the square root. This square root will be what? Will be half exponent negative half times what? Times 2x plus square root of x. Now we are done. After doing, what did we do so far? Okay, let me erase this before it gets confused. What we did so far is, okay, now if you check, we did the square root, then after square root we went inside square root, we did this whole thing. But this whole thing, when we got to this square root of 2x plus square root of x, we did only the square root. Then which means after that square root we have to go inside, which is here. Then if we go inside there, what do we have? We have 2 plus square root of x. If we derive square root of x, we have half x exponent minus half there. Then now we are done. Just go through it again. I can try to explain it again. Remember, this is the main function. We started with it. Main function, multiply by 1, we got half. We subtracted 1, we got this. We are done. Then now we go inside. If I go inside, I derive Remember, when you deal with half, there's nothing else you do, nothing changes. That's why the inside did not change. Then after that, you multiply by the next function, which is 3x, which is 3, plus that square root, which is half, and minus half. Then this. Then after that, this is part of this square root only. If you multiply that square root, the inside of that square root, you derive 2x, you get 2, plus the derivative of square root of x, you get that. Okay, let's do another one. We have only three examples for this. So let me go to November 2019. Quick. Okay, here's November 2019, question 2 point. And your chain rule is always there. And sometimes it's not one question, it's 2 or 3. Like this one I'm doing here, question 2.3, we have 2 questions. So I'll try to do 2 of them. We have tan cube. Okay, let me write that properly. Let me not be lazy. We have tan cube square root of cot 7x. Cot 7x. There. So we can see that the square root is only for cot, and cot is part of your tan. So this is the same as saying tan square root of cot 7x. Then the cube is for the whole tan, like this. So now the main function is cube. Do we agree? If I start with cube, I have 3 tan squared. You see, nothing else changed. It's only the cube. Then after the cube, what's the other function? It's tan. If you derive tan, you get sec squared. This does not change. Then after tan, what's the main function? It's half of your cot. It's exponent. It's the square root of the cot. It's not yet cot. If I start with square root of cot, I'll have half exponent minus half. But cot does not change. Now I derive cot. If I derive cot, you check the formula sheet quick. The derivative of cot is negative cosec squared. But this is cosec 7x. Then after cosec, after cot, you have what? 7x, which is 7. And you are done. You don't simplify, guys. You don't simplify. You leave it there. You see, that was number 1. Number 2, they give us 10. Why it's 10? Then we have square root, we have 1 plus bracket, we have 2 minus bracket. This ones I don't like them. You can easily make mistakes with so much bracket. Then the first bracket closes is exponent 9. The second bracket is exponent 3. The last one is exponent 5. Yeah. Then derive that. So we don't have to simplify anything. We can see the main function is exponent 5. Exponent 5 times 10, we have 50. Then what's left? We are left with exponent 4. Inside the bracket does not change. This is still 9. This is still 3, 4. Then now we are done with exponent 5. Now we go inside. Inside, if I derive 1, I get 0. Now after 0, I must go to this bracket for exponent 3. The main function, that's exponent 3, which will give me 3 exponent 2. Then inside the bracket does not change. I have 6 plus 7x exponent 4. I still have exponent 9. Then now we go inside the bracket of that 3. I have 2, which will give me 0. Then minus exponent 9 now. If I do exponent 9, I have minus 9 exponent 8. Inside the bracket does not change. Then now I'm done. Then now I can go inside the bracket. I have 0 for 6. Then I have 7x exponent 4, which is 28x cubed. Just like that. You do one thing at a time. Okay, let's do the very last one. Okay, let me quickly open it. Let me go to April April 2019. I hope I have it. April 2019. There. Okay, April 2019, question 2 point. Okay, we have two of them again, so I'll just do two of them. I have question 2.3. I have tan open bracket. I have cube root of 3x squared. Then I have plus ln 5x exponent 4 close bracket for tan. So let's start. You can see the main function is tan here. Tan doesn't have exponent, right? So if I derive tan, I have sec squared. Sec squared of what? Of everything inside your bracket. Remember, one thing at a time. Nothing changes. Now I'm done with tan. I can go inside the bracket. So I'm multiplying by what? The derivative of this. Remember the cube root. You can write it on the side. The cube root will be the same as 3x squared exponent 1 over 3. So if I derive that, what do I have? That 1 over 3 times 3, or it will be only, okay, I can't multiply it with 3 only. I must multiply it with the whole thing. So it will be 1 over 3 x squared exponent 1 over 3, we must subtract 1, exponent minus 2 over 3. Times what? Times, okay, I want to show you this one. This one is important. Times the derivative of 3x squared, which is 6x. But instead of doing it like this, just simplify this. Remember, this 1 over 3, you can make it be part of 3 and you can remove x. X will be what? Will be 2 over 3. You see? So now if I'm going to derive this alone, like this, the 2 over 3 will multiply the square root there. So instead of making it complicated, the 2 over 3 multiplies square root. Then I have square root 2 square root 2 square root 3 over 3, because the 2 over 3 multiplies square root. Then x, I subtract 1, I get minus 1 over 3. See, just like that. Then I'm done with this part. Then plus, now I'm going to the ln. Ln, first thing is 1 over everything there. Now times the derivative of that part, which is 20. Okay, my pen is trying to jam. It's 20 x exponent 3. If it's 4 times 5 is 20 x exponent 3. Then you are done. Don't simplify, guys. Remember, don't simplify. Okay, yeah. That's it. Yeah, we'll talk again next time when we do something else. Please don't forget to practice more.